Welcome to The Explainer. Today, we're diving into one of the biggest, most exciting leaps in AI, agents. We're not talking about AIs that can just chat about doing something. We're talking about AIs that can actually get things done in the real world.
Look, we all know large language models are amazing at spitting out text. You want a poem, an email, you got it. But there's a huge difference between talking about a task and actually doing it. You know? How do you get an AI to go beyond just describing a flight itinerary and actually browse the web, compare the prices, and then book the ticket for you? Well, that's where AI agents come in.
So here's our game plan. We're going to break this down into 5 parts. We'll start with what an agent even is, then walk through building your first one and what to do when you need a whole team of them. After that, we'll get into the essential tools they need to function, and finally, we'll tackle the single biggest problem, making these things actually reliable.
Okay, first up, what actually makes a regular AI an agent? It really boils down to that critical jump from just generating words to taking real action. It's the move from talking the talk to walking the walk.
Think of it like this. An AI agent is basically an LLM that's been given a mission and, crucially, a toolbox. The language model acts as the brain. It can reason about a problem, come up with a step-by-step plan, and then, this is the key part, it uses tools like APIs or bits of code to actually execute that plan. This whole concept really took off with a paper called REACT, which literally stands for reasoning and acting.
The real power of an agent comes from this constant loop between thinking and doing. First, it reasons. It thinks, okay, what's my next step? Then it acts, using a tool to get something done. It sees what happened, and then it goes right back to reasoning to figure out the next best move. It's this cycle of thought, action, observation, thought that lets them chip away at really complex problems. All right, so now we know what an agent is, but how do you actually build one? That brings us to our second section, and really the first huge decision any developer has to make. Which framework are you going to use? And right away, you hit this classic trade-off. You can go with a high-level framework like Crew AI, which lets you get up and running super fast. Not a lot of code, but that convenience has a price. Analyst Cole Medin calls it an abstraction distraction. It hides so much of what's going on that it gets really hard to customize or figure out what went wrong. The other path is a low-level tool like Pydantic AI. Yeah, you'll write more code, but you get total granular control. And this is why a lot of serious developers end up choosing those low-level tools. A library like Pydantic, it isn't just some new AI thing, it's a fundamental building block of the entire Python world. We're talking 360 million downloads a month. It's battle-tested. When you build on something that solid, you're not just getting a tool, you're getting a guarantee of stability and a massive community that has probably already solved your problem. So a single agent can do a lot, but just like with people, really tough problems, they usually need a team of specialists. So what happens when your task is just too big for one agent to handle? Well, you build a crew.
The best way to do this is what's called a mixture of experts. Instead of having one generalist agent trying to be good at everything, you build a team of specialists. You might have one agent that's a pro at searching the web, another that's a genius at data analysis, and maybe a third that just writes code. But of course, a team of experts needs a manager, a leader to coordinate everything. And that's where orchestration comes in.
A tool like LangGraph is an absolute game changer here. It's basically the project manager for your AI team. It lets you design exactly how your agents should work together, who passes tasks to whom. And maybe most importantly, you can build in checkpoints for a human to step in and approve critical actions. It takes what could be a confusing black box and turns it into a clear, visual flowchart of your agent's entire thought process. So we've got our team of agents. We have an orchestrator telling them what to do, but where do these agents, do their work? They need a workshop. A safe, secure environment where they can run code and use their tools. Let's just zoom out for a second and look at the whole tech stack here, based on a great diagram from A16Z. We've already talked about orchestration with LangGraph and the LLM APIs that are the agent's brains. But I want you to look closely at that fourth piece, the agent runtime. This is one of the most critical, and honestly, one of the most overlooked parts of the whole puzzle. So why is it so important? Well,
think about what you're asking the AI to do. You're telling it to write and execute its own code, to browse the internet, to mess with files. You absolutely 100% cannot let it do that on your main server. That would be insane. You need a secure, isolated sandbox, a little digital playground where the agent can do its thing without any risk to your systems.
And that's exactly what services like E2B AI sandboxes provide. It's like spinning up a secure virtual computer just for your agent, whenever it needs it. This is what lets you confidently give an agent a really complex job, like analyzing a massive dataset or running code it just wrote, because you know it's all safely contained. This is the kind of tech that companies like Perplexity and Hugging Face rely on to power their most advanced AI features. Okay, we've built our agent team, we've given them a safe place to work, we're all done, right? Not even close. Now comes the hardest part of all, making sure the darn thing actually works every single time. This is where we go from a cool demo to a product people can actually rely on.
And let's just be real for a minute. This quote from A16Z hits the nail on the head. A lot of agent systems out there are still more demo than product. They can pull off these incredible one-off feats, but making them reliable, that is the central challenge in this entire field today. Which brings up a huge question. How do you even start to fix a system that literally thinks for itself?
The answer is observability. If you can't see what's going on inside the agent's mind, every thought it has, every tool it calls, every bit of output, then you have zero hope of ever debugging it. Observability tools are like getting an MRI for your agent's brain.
And the scale of this problem is just staggering. You've got platforms like Arise that are processing 1 trillion of these little AI events every single month. You've got frameworks like Llama Index with over 4 million monthly downloads. This isn't some tiny niche issue. This is a massive industry-wide race to make AI trustworthy.
And the way you solve it is with this constant evaluation loop. It all starts with tracing, logging every single thought and action your agent takes. Then you evaluate those traces to see how well it did, often using another AI to act as a judge. When you find a failure, the trace helps you pinpoint the exact root cause. And finally, you iterate. You tweak a prompt, fix a tool, and then you start the whole cycle all over again. So if there's one thing to take away from all this, it's that building a single agent is really just the start. The real work, and frankly, where all the value is in building, securing, and monitoring a reliable team of agents that can solve hard problems day after day.
Which leaves us with one last question to chew on. As these AI systems get more and more autonomous, more capable of acting on their own, what's the one job that we can never, ever afford to automate? Maybe, just maybe, it's the role of that human in the loop, the person who gives the final okay, the final point of accountability. What do you think?